Fortunately, in 1960, anthropologists from the University of California filmed Homer Cooper practicing an ancient art which had been passed down to him through generations. This art was the practice of composite bow construction. 51 years later, I will try to reconstruct a comparable weapon using the exact same materials and methods, with the only exception being my use of steel tools over stone tools. What made the bow composite was its use of multiple materials to create a more compact weapon. In the case of Homer's bow, these materials were tendons from a deer or elk, the swim bladders of large bottom-feeding fish, and wood from the famous yew tree. After being split into quarters, the wood is further reduced using a hatchet. Then it is flattened into a board, perfectly following the grain using a draw knife. It is important to use hand tools because of the precision required to follow a single growth ring. The bow's rough shape is hacked out with a hatchet. The handle is then scraped out using a rasp. It's then given its final shape using a more precise file. The wide, thin-limbed shape of a California-style composite bow begins to emerge. After being boiled for half an hour and forced around a round object, the tips are then leaned on to create a recurve. The bow is nearly ready for its lamination of sinew. However, first the glue must be prepared. These fish air bladders have been soaking in water for 48 hours. After being finely chopped, the bladders are cooked at 170 degrees for 30 hours. The resulting glue is a thick, viscous paste made of almost pure animal protein. Now the sinew must be processed. These elk heel tendons are beaten until their outer casing can be removed. The almost translucent bundle of sinew fibers inside is revealed. This inner bundle is then beaten until individual fibers can be teased apart. It's hard to believe that the resulting thin, white, fluffy fibers are a product of animal tendon. The knots are then scraped out so that the bow can be strung in reverse. The lamination will be applied while the bow is in this condition, incorporating what is known as pre-stressed construction. Since the bow will eventually be strung in the opposite direction, this will intentionally place a great deal of the bow stress on the sinew fibers. The sinews are divided into equal groups and passed through with a comb to make sure that there's no knots. A piece of the fresh fish bladder glue is cut and re-liquefied using heat and water. Finally, the bow is resurfaced and covered from tip to tip in a thin, watery solution of glue. A hot, thick solution of glue is then spread over the thinner solution. The sinew fibers are then laid down and massaged into the viscous layer which awaits them. The purpose of going through all the trouble of lamination is to create a layer in the bow which will take the stresses off of the wood. The result is a much shorter weapon that can withstand a more extreme bend without sustaining damage than a bow that was only made of wood. This compactness was undoubtedly appreciated by the hunters who encountered dense brush here in Northern California. When the first layer of sinew dries, 2 more layers are simply applied directly over it until the bow is covered from tip to tip in a thick caking of fish glue and animal tendon. After a few weeks of seasoning, the bow has retained the desired reflexed shape. The bow must now be opened up and tillered. Tillering is the process of teaching the bow to bend evenly, through repeated flexing and scraping in the stiff areas. Once tillering is complete, the bow is finally ready. Golden Gate Park in San Francisco is a great place to take a few practice shots. At 18 meters, at 20 meters, and even at 35 meters, the bow demonstrates an impressive cast for its small stature. Stepping into the redwoods with such a weapon, it's difficult not to feel a certain sense of correctness. The people who built these weapons designed them specifically for hunting in these forests. It's probably been centuries since a sinew-backed Yew-Bow passed through this grove of redwood trees. However, I pray that anthropologists and hobbyists will continue to be interested in this magnificent piece of technology so that it won't be the last.